Okay, so if Mrs. Vote was going to rank Oreos, she would only choose regular Oreos, like double stuff and regular. I would maybe try the peanut butter one, but like I've maybe try mint, but I would not try these, and I wouldn't try these. And the reason is because they taste bad, and then it like makes me not want to eat Oreos at all. So I stick to the classics. I do golden Oreo, regular, double stuff, mega stuff, ultra stuff, but I'm not gonna try all the weird flavors. So is that an unpopular opinion? Maybe. Okay, so we're gonna talk about radicals. And this is a symbol you've probably seen before, and we're just gonna review like this is square root. Okay, so we don't ever see the little like the little two here. And that's the only one that you don't see the little two on. Okay, call this one a cube root. Okay, and then after that they kind of run out of names, so we call this a fourth root. Okay, nothing special. All right, so these are radicals, and hopefully you remember doing things, and we've also talked about imaginary numbers for like this even, like squared. Odd would be like third to the fifth, seventh, fourth root, sixth root, eighth root. Anytime you have an even root, whatever is underneath the square root or the fourth root or the sixth root has to be greater than or equal to 0. And why is that? Because if we remember when we were talking about like stuff like this, right? We called the answer this, an imaginary number. And so as we're solving these, we only want real answers. So the domain or the types of numbers that I can put in here are anything that makes under the radicand, under that symbol, positive, 0 or positive. Okay, so you'll often see me saying like, check the domain. It's taking what's in here and taking that and making sure that it's 0 or bigger. If it's less than 0, that means it's a negative number. And a negative number we can't take the square root of and get a real number. For odd functions, though, that just simply is not the case. So like if I take the cube root of negative 8, it's negative 2. And I can also take the cube root of positive 8, and it's positive 2. So thirds and fifths and seventh roots, the domain is all real numbers all the time. So you don't have to be as careful. Okay? But so remembering about the even, that it does have to be positive underneath the radical symbol. Okay, so let's try some here. And remember, when you're watching videos, you should pause and slow down. All right, so identify the domain. So this step, we're going to look and decide, do I have an even or an odd radical? I have an even radical, so I need to take this here, x plus 7, and make sure that it is greater than or equal to 0. So I'm going to solve, and I want all x's greater than or equal to negative 7. So I've identified my domain. Okay, step 2 is isolate the radical, and that means to get it by itself. And you'll see here, if I'm looking, there's nothing touching the radical. I'm not multiplying by a number, I'm not adding a number at the end, any of that kind of stuff. So step 2 has been taken care of. Isolate the radical means get it alone, okay? Meaning there's nothing multiplied in front of it, there's nothing added to the end of it, and so on and so forth. Okay, then it says perform inverse operation to cancel the radical. Well, to get rid of square root, I square. And if I do it to one side, I have to do it to the other. Okay, so that's step 3. I have 25 equals square undoes square root x plus 7. Okay, then I'm asking you to solve. Okay, so I get x equals, what is this? 18, if I added and subtracted correctly. And then you should compare. So we were doing this before, right? And I would have us check, is 18 greater than negative 7? Yes. So we can keep our answer, and it's good. So just like when we were checking for those extra solutions, remember I told you that word was extraneous? When we check for those solutions, you will sometimes find answers that just don't work. All right, example number 2. I'm going fast because I only have 13% left on my iPad and I need to plug it in again. All right, so identify domain. I asked myself this, is it a even or an odd? Okay, and I put a little there. This is an odd one, so any number can be my domain. I don't have restrictions for this one. Okay, isolate the radical. Look I do have something. If I circled my radical here, I have something on the outside that I need to get rid of. So the first step in isolating the radical is to move it to the other side. I just copy down what I have, cube root x plus 2. Okay, identify, isolate, perform the inverse operation. Because it's cube root, I need to cube both sides. Now remember, a cube can be a negative number. -4 times -4 is positive 16 times -4, I believe, is negative 64. I make lots of mistakes, so I'm sure that if I did that wrong, you guys will tell me about it. And now I just need to solve. And I get x equals negative 66. Okay, and then I need to just look at this here and compare it to my domain. But the thing about it was an odd, so I don't have any domain restrictions, so I am good. All right. You should also probably check your answer. I did not mention that. But plugging it into check is always a good way to see if you are correct. Okay, last example today. Identify the domain. I'm looking and I have fifth root on these. So my domain of an odd is all real numbers. Okay, then I have isolate the radical. And even though both sides have a radical, they are isolated. There's no adding on top of them. There is no multiplying to them. So we've done that part. Okay, perform the inverse operation. Well, I need to take both sides to the fifth power. All right, so that doesn't look too bad. And now I'm going to solve. So -3 equals 4 plus n. Okay, and what happens is I can then compare these two. Okay, compare it to the domain. Because it was an odd function, I am okay. So from here, I just need to, this is my answer, and I might want to plug it into check. But other than that, we have completed our first 3 examples, and I'm going to plug my iPad in so it will charge.